Okay, so here we have another session of nTop Live. Today we're going to be focusing on a custom midsole design using unique geometries brought into the system. My name is Annika Norden. I'm a customer success engineer here at nTopology. Just for a little background, that means that I'm working with customers as you're starting to onboard with nTop and really get you started so we can get into fun applications like these really as soon as possible. So this is a pretty exciting workflow. Just for a little bit of background, this workflow was originally created for a helmet. So if you imagine these little geometries like this as some sort of padding infill for impact absorption within a helmet. That was why I originally created this workflow. But again, because we're learning that a lot of these workflows can be used in many different applications, I realized that to fill a shoe sole with the same kind of technique could be a new and exciting way of creating a custom infill within a shoe. So I have the workflow already done here. We're going to keep it pretty simple and quick today, but again, we'll be able to share this file as well, so you'll have access to dig a little deeper if you are curious about what's going on behind the scenes with this workflow. So just to start, I began with some initial meshes. So if I isolate some of these views, we see we have this imported body, and this is the entire shoe sole. But in addition, I have this base mesh as well. The reason that this body looks a little bit different, let me just turn my wireframe back on so we see that it's that traditional mesh with those triangular faces as well as this sole. But the next thing I did was turn these into implicit bodies. And so for those not familiar with nTop, not familiar with what an implicit body, this means that I'm taking this volume that I see before as this STL mesh type and converting it into our field-like implicit body. The reason I do that, you'll see in a little bit, because I want to be able to work with this geometry, work with this body as a field to help drive this workflow that I have. I also did the same with the sole, gave it a little bit of thickness so that it too can work as a field. So what I have is I began with a list, some random points on a mesh. So random points on mesh, this is a really easy plot where I can bring in a mesh, define how many points I want, define how relaxed I want these points to sit on this mesh, to then create a bunch of points that span across this mesh. So as you see, we have 50 points. You can see I entered 50 points into this input, but then also you'll notice that as I have those 50 points, I now have this list of points, which you can tell by the fact that next to this block, I have 50 in parentheses here. So now nice and evenly spaced, because I have 30 as my relaxation iteration. If I wanted to ensure that it was even more evenly spaced, I could bump this up maybe to something like 1000. So I know everything is kind of pushed around and nice and even. But in this case, I'm satisfied with how this looks. And I have my 50 points along this surface. And so what I'm going to do, I think this is a really great block. So the closest point block, what that does is it takes a list of points, either one or more points, and it will pull those points to whatever specified body and whatever closest location that is. And so this is easy to do when you're bringing in an implicit body, because really, again, we're working with that field. So by bringing in a field and taking a bunch of points that, in this case, are just along a plane or along this surface, but in other cases could just be floating in air, it's going to pull all of those points right onto the surface. So that's what I'm going to do here, so that I can bring my points onto the top of my body. So if I turn this view on, you see all of my points are sitting right along that surface there. And then the next thing that I'm going to do is use the sole of my shoe to bring those points that I have up above and pull them right down to the bottom. So if I isolate these points and then turn on my sole, you'll see these are all sitting right on the sole. And because the sole is right at the bottom, these are also sitting at the bottom of this volume here. So what I did, I had those starting points, I shot them up to sit on top of my my midsole, and then also brought them back down to sit on the bottom. And so did that for a couple of reasons. One, just so I have nice points that I know are spanning equally from the top to the bottom, but also because within this capability, we get a couple of exciting properties out of the closest point block. So if I go into my properties here, you'll see that I have a few different things. I can grab onto the size. That's just the 50 points that I have in here. I can grab onto the distance. So that's the distance that these points moved. So in this case, I'm going from the top of my shoe down to the bottom of my shoe. So this distance value here is the distance that each of these single points traveled to get to the bottom. So this is very important because I can just pull this distance value, which I did here, and then I rename that as my height. Because if we think about the distance from the top to when it's being shot immediately down to the bottom, that's going to be my height that's varying as I'm working through this midsole. What I also grabbed, which is important, is the normal. So with the closest point block, because you're bringing in a field, you're bringing in that implicit body. As your point is pulling to that implicit body, it's very easy for it to read in what the normal value from where that point sits on your body. So I also grabbed normal from there. You'll see it's sitting on my notebook here because I wanted to extract those because I know that I'm going to use those later on. So placing the points where I want them to be, but also finding the height between the points. So actually, let's turn on this visibility so it might be a little bit easier. So the height or the distance and height between each of these points, and then also the normals from the base, so that when I'm clarifying my geometry, then it's gonna be a little bit more helpful to understand where things are going. So first, I'm gonna start off with some simpler geometries. So as some of you might know, we do have some primitive options, primitive geometries that we can create directly within the software. So two that I like, just because of how they're built, are the cylinder and the cones. So if you look at the inputs of the cylinder and the cones, you'll notice that it asks for 0.1 and it asks for 0.2. So if I'm just building one cylinder, I can define a point maybe at the origin, and I can define a point maybe 5 millimeters above the origin to create a cylinder from there, then giving it a radius so that we have a little dimension to it. And the same goes for the cone and how I'm defining the top point, defining the bottom point, and then also giving a radius for either of those points. But the reason that these bodies work very well with this workflow is because I'm also able to bring in a list of points. So I have 50 points in each of these cases, right? So as I started with that 50 points, I use the top points and those 50 points float to the top. I use the bottom points, those 50 points come down to the bottom. So we're still working with that even number of points. So with 0.1, I brought in my top points. With 0.2, I brought in my bottom points. And if I turn on this view, we'll see how quickly that generates that. And we have this nice variable height so if I look at my mesh here, how it kind of fills in those spots, as you can kind of see through that. We have the taller ones filling in exactly those locations, and then those shorter ones, you see that they're squished a little bit more, but because we have those points coming in, it fills those in properly. And so same goes with the cones. This is just a little bit different. I think this is kind of fun, like having that spiky fill within a geometry. But because, again, we're able to read in the top point and the bottom point, this is pretty simple to do. But maybe we want some kind of geometry that isn't made within the software, or perhaps we can't just bring in, define a top and a bottom point as simply. So what I did was I actually imported this little CAD part. And so I thought this was a nice geometry that could fit and fill our area that we have here. I did a little manipulation to start. First, I converted that to an implicit body. Sorry, let this take a second to generate. As we can see here, so now that it's an implicit body, we're working with that new field type form that's going to be very easy to manipulate. Then I scaled the body down a little bit. just because I want it to be a little bit smaller so that it can fit into the area here. However, if I look at the scale object block, we're just scaling it by a factor. So if I'm saying 0.5, then the whole entire body is going to shrink to half of the size that we originally had. However, I want to keep that constant diameter, but instead, but still make sure that my heights are varying so I can properly fill that geometry. So what I'm going to do in order to do that is actually create a remap, or I'm going to remap that field. So here we have this little field, and this is my geometry here. And so all I want to do, so if we look at this gimbal, we see we're working in that Y direction. And all I want to do is push and pull along this Y direction so that it fits properly into the heights of my shoes. So with a remap field and with a couple of multiply blocks, I can accomplish that, or sorry, math blocks. So I have a multiply and a divide block. And so really what I'm doing is just scaling this geometry just along the Y axis. So my X and my Y, my X and my Z, I want to keep constant, right? Because as I said, I want to keep this constant diameter here. However, I want to change that Y. I want to push and pull it. So you see I have this 25 value. That's because I know the height of this geometry is 25 millimeters. And so I'm dividing that by height. So kind of creating a fraction here so that all of these heights that I'm bringing in, and if I look here, we can look at the values. We have all of these differing heights, right? So if by the looks of it, it looks like we're ranging between 20 millimeters and getting down to as small as around 2.5 millimeters. So we have all these different heights. So by just creating a quick little fraction and multiplying that Y value by that fraction, then we can take those heights and return the heights that we're looking for. And so I'm not going to turn on the visibility of this one just because all of them are overlapping. So we're not going to see anything there. But now, because I have this remap and because we're still working as a list, right? As we can see by this 50 here, we've properly scaled all 50 of these bodies. But right now, they're still sitting where they are now along this same axis because we haven't moved them yet. So the next step is actually to orient those. And so this is where my normals come into play. So we have an orient object block where you can take an object, and the object that I'm taking are these 50 little remapped geometries that I have. And I take a source plane. So if I turn on my source, you'll see that I already plopped my source right at the base of this geometry that I have here. So if we think about orienting an object, we have a source. So my source is right along the base that I'm going to be moving around. And then we need destinations. And so for the destination, you'll see that this is, again, I'm bringing in that list of 50 because what I'm doing, so again, this is just a plane for normal block that just asks for an origin and a normal. In this case, my origin, I'm putting right at the base of my part here, and my normal is just going up in the Y direction. However, if we're looking at these points that I have here, so again, let me turn off this one, these bottom points that are sitting along this sole, we have all of our origin spots, but because we see that the sole is kind of moving around, we want to make sure that all of our normals come into play so that each of these objects is sitting properly on that face there. So what I can do is actually bring in my origin as these bottom points. So these are the bottom points from this closest point block. And then my normal is going to be all of these normals that I grabbed from my closest point block as well. So let's see, if I turn on this view and shift this over here, then we can see that all of these normals are following the curvature of this bottom one. And so this is important so that they're sitting there properly. This is also why we remapped first and then placed them, because if we were to place them first, if I look along here, they're not all along the same plane, right? We've got this curvature. So if I were to try and remap once they were already placed along the y direction, then there's going to be some distortion and some pushing and pulling, which is why I want to remap them first while they're all in the same orientation. And then from there, I can orient them. So let's see. So with that, you'll see that I have all of these different heights oriented properly along the base of that plane there. And so this is because, again, I took those points, I created the top points and the bottom points and grabbed onto the normals and the heights. So I could then scale it, or sorry, remap them and scale them with the height and then orient them along those normals from there. But let's say I wanted to take this to the next step, change it up a little bit. Maybe perhaps I have some pressure data that I can bring in so that I can really optimize this geometry here. Because right now, if I did a section cut on here, we'd see that these are all solid objects. But maybe to give it a little bit more spring, I want to hollow them out. And so when they're produced, maybe they're printed, maybe they're molded in some kind of way, but they have a little bit of thickness to that and that open space so that we can give it a little bit of bounce. However, I have, again, we're still working on these shoes, right? And we want them to perform properly. So by bringing in a pressure map, so I have a pressure map in here, by bringing in a pressure map and scaling with that pressure map. So our pressure map, we've got a little bit more pressure in the heel and along the toes, also along the side, as you'd imagine with a foot and the kind of weight that acts on a shoe sole from there. So I can bring in a pressure map. I can define my bounds with a ramp block. So I'm working from the different pressures and outputting a different variable shell from there. So if I turn on this view, it looks a little bit funky. That's just because I'm working in medium resolution. But if I hit my X here, and you'll see that where we have the higher pressures, I have a little bit thicker of a shell there. And then where we have the lower pressures, maybe in the middle, then we have a bit of a thinner shell there. So as we're working through this model, maybe it's better if I flip the direction of this. And you can see how those pressure, those thicknesses are changing from there as we have the difference in pressure. However, with that map, we could do a couple of different things. So if we wanted to take this to the next level, maybe use that pressure map to drive the location of these geometries, or maybe use that pressure map to change the actual output geometry that we're creating. In this case, this is a little geometry that I brought in from CAD, but this could really be anything. But also being able to use this pressure, or just different fields to play with this infill in general, I think has a lot of power. So here's another example. You'll notice that the way that we have these initial points are spaced a little bit differently. So if I open up this point block, so I actually have ramped these. So with this one, I'm ramping it from a plane here so that we have more dense spacing over here and then more open, because maybe this is for aesthetics, maybe this is for performance. We know we want more dense spacing within the heel, but really whatever from there. And it goes, we're gonna follow that same exact workflow where we're having the top points and the bottom points. But just for quick visualization, I'll just use it with the cylinders here. We have this nice dense cylinder over here and then more open here. But again, because we're just working along these fields and playing with that in that variation and modification, it's very simple to just be able to jump into these things and quickly change around some of these parameters until we find the design that is working well. And from there, maybe run a FEA analysis on it. But a lot of different potential that we can do within this workflow. And I think this is just to really get started on things. You'll have access to this file to play around with it a little as well. So in playing around with that, kind of seeing the next steps and how we can use other fields to drive that, whether it's for aesthetics or whether it's for performance. I think it's very exciting because a few of these nTop lives that we have covered midsoles and shoe designs, but you'll notice that there's a lot of different capabilities with these. Some of them first looked at texturing of the midsole. Other examples that we have online are as well bringing in a pressure map and working with like a Voronoi lattice. But this is just another option where you're able to bring in some kind of geometry, whether it's created within nTop or created outside of nTop, to then drive that design and fill up a space for aesthetics and for performance, and to really work from there. So that's it for my workflow. Thanks for tuning in. We have other nTop lives Monday, Wednesday, Friday, every week at 11. So be sure to check those out. Also, check out our page online because there's a lot of great resources as far as the workflows that some other team members are sharing. So definitely urge you to check those out, and hope to see you again soon.